We're at Vincent Corporation in Tampa, Florida. This is the 16th of July, 2024. We're running a test with a very unusual material. We have the 4 or 5 gallon pails, and this is a press liquor from a screw press. That's what we believe it is. And the complaint was that the fluid is jamming the spray nozzles in a field irrigation system. When we stir this up, we don't find any solids accumulated on the bottom. One of the first tests we ran was to get a small sample of this, put it in a glass vial, let it sit for an hour. A little black layer formed at the bottom, but we weren't getting gravity decantation. By gravity, the stuff doesn't separate out, the fiber insoluble solids. Another test, we took a sample from each pail and ran a quick test on it for the solids content, and it has 4.8% solids. That surprised us. Looking at this flow, we thought that was a lot less than 4.8% solids. Then we ran a refractometer test with bricks, and consistently we got a reading of about 3 degrees bricks. And those are dissolved solids. If this is material that's gone through a biogas digester, we know it would be mostly salts. If it's just plain old manure, something going into a digester, that's probably mostly sugars. But anyway, we read 3 degrees bricks. Next test, we did the sock test. That is, we took a pretty good sized sample and put it in the cotton cloth and twisted it into a ball. And actually that was the second test. I'll tell you about the other one in a minute. And you can see the fiber we got on the cloth, but the peculiar thing that we hadn't seen before is the cloth would blind over from this fiber, and the water couldn't be squeezed out despite a real tight twisting. And we did quite a bit of messing around to get out that much liquid. The liquid came out clear, but you just couldn't squeeze it through the cloth. Another test we did is we took a sample of this material, or half a pint or so, and poured it down the face of a side hill screen, a static wedge wire screen with 20,000 slots. And that one surprised us because quite a bit of fiber stayed on the outside of the screen. We may duplicate that test with one of these buckets in a little while. But seeing that the cloth is blinded by the fiber, somehow it sticks together and prevents water from going through, we don't think the screw press is going to work. Nevertheless, we've put together this press and just now, and it has slots that are only 6/1000ths of an inch, of 150 microns. If I open the cone here, in here you can see these very tight slots, and we're going to pour a bucket of our sample in here and see what happens. I'm predicting that water will come through the screen at first, but then quickly the screen will get blinded and the press will stop operating. We'll soon see. If that failure turns out the way I think it will, we're going to try a little laboratory fiber filter. This fiber filter uses a fabric sleeve. I saw some here, and this is a sleeve, very fine micron. Here's this sample. I read 46 microns, and it's a little coarser, but we'll try that in the fiber filter in case that's what we need to do. Okay, we're getting ready to that's Flo, our chemical engineer, new in the company, doing practice. Oh, first of all, here's the screw going around. We've got it going. You can see it's probably running about 20 RPM. Go ahead and pour it in. Pouring in the sample here. And I should see some liquid come through here. Oh, shoot. I'm closing the discharge cone. It was purging out. Now, if I can form a plug there, it's starting to form a plug, and I probably lost all my sample. Nope, I've got fluid in here. Look at that, the level is not going down because the screen blinded already and it's not letting any water through the screen. That fiber, boy, you make Velcro out of it or something. It sticks together and it's preventing any liquid from coming through the screen of that press. And that's what I expected. I could have used a wider slot than the 006 6/1000th of an inch, but I'm afraid the same thing would have happened. So I'm going to scratch a screw class for now. This is too interesting a shot. We're down in the assembly area and we're loading out this press. The customer wants to haul it from site to site, mounted on this trailer. And so this is how we're loading it. We had a chainsaw. We cut that piece of timber into 3 pieces this morning. Looks like a BP16 press. On the small side of the big range. Oh, there's a fiber filter. And there's another one. These are 30-inch models, good for 500 gallons a minute, depending. Assembly area over in here, 1 press, 2 press, 3 press, 4 press, 5 press, 6 press. 3 presses are us, but this one's going out the door. Okay, that was the big fiber filter you looked at, and this is the small one. This is a 3-inch model for testing. We're going to run a pail of stuff through it. It's got a pretty fine mesh sleeve in it, but we'll see what it does. Incidentally, we left this press running, been running an hour and a half now, and in 1.5 hours we brought the level down, about 1.5 inches. I'll try opening the discharge cone here and we'll see what happens. Hit the air pressure and the liquid's still draining out. I never formed a plug of fiber and never got any fiber or press cake to form. And yeah, bad. Anyway, next test, the fiber filter. Okay, there we go. We're going to pour a bucket in there slowly. The highway department contributes to our program always. They give us these funnels for free. And he's pouring a little bit in there. And there's our no liquid coming out there. Nothing there. A little bit of sweat coming through. Okay, there's our filtrate. Here's our sludge. It's going to start raining, but early this morning we poured a couple plastic baggies, and you see the fiber accumulator. This screen has 20,000 slots. It's designed to bolt onto the end of a inlet to a screw press, and what we're going to do is pour our buckets down here, down the center slowly, and see what happens. 20,000 slots. Yeah, that's about the right speed. This is sitting at a slight angle. Okay, it's going to flow over. We've got a little more gentle than it was designed for. It's maybe 15 degrees off of horizontal. We'll see if we can form some sludge at the bottom, or if the screen is simply going to blind over and everything flow off the end without any filtration. A decanter would work on this. Yeah, a decanter might be the answer. There's some people make decanters from manure, surprisingly inexpensive compared to the GEA Westphalias and the Alpha Lavals. You can see it's thickened a little bit coming off of there.